Hello everyone and welcome back to the Doroni Podcast. I'm really excited for episode 2. Today we have a phenomenal guest, Barger, our Chief Electrical Engineer. We're going to go into the depths and challenges of the Doroni technology. For those that are new to Doroni, Doroni is on a mission to elevate personal transportation by developing electric vertical takeoff and landing vehicles known to many as flying cars. This podcast, we're going to be sitting with our team members, going through the challenges, the successes, the milestones, and how we're bringing our H1-X model to life that we're aiming to deliver by 2026. Okay, without further ado, let me introduce you to Barger.
Hello.
Okay, I'm really looking forward to this episode. You know, you were one of my main mentors and people that I've learned so much about this industry and technology when I came into this company. So let's dive in. Let me ask you, Derek, so if you can bring in our followers, our investors, and people that are interested about Doroni, can you start with giving your background and what led you to get into this field and build the H1-X?
Oh boy, that's a long story.
Okay, we have time.
I won't go into that much detail though. But basically, I've been doing electrical for a very, very long time. My grandfather even taught me. He was an electrical engineer as well. So, I've been many different jobs over the years, many different things. But mostly recently, before lithium cells were popular, I was in lead acid, doing lead acid things before that, with electric equipment. The thing that got me, mostly involved was the electric vehicle racing that I did. So a friend of mine got me involved in that, Steve Sikora. So he was the one that got me. We were building CNC equipment at that time together, working as a hobby before it became popular as a hobby. And then I started working with the teams, the racing teams, building electric vehicle batteries, mostly for motorcycle at the beginning.
Mm-hmm.
So
that was in what years? What was that?
It was started around 2000-ish. I mean, we were before that we were preparing, but in 2003 it really ramped up. We were doing lead acid still on vehicle racing before that. So yeah, lithium's when it really got really big.
Got it.
Lithium
So
cells.
in 2003, where you started working with electric batteries, electric vehicles, I believe, right? That was even before anybody else was looking into it. What was the stage at that time?
No, I mean, there's been over the century, last century, has been lots of electric vehicles been built, and even in the 1900s, 1909, 1907, there was a lot of electric vehicles built in the United States. A lot of big companies, actually. Yeah. So what has changed was they were using, nickel iron chemistry back then. They were also using lead acid chemistry, and then they were using I think it was nickel cadmium cells, NiCads, as well as magnesium cells for electric vehicles. So they started, whatever the latest technology was, the electric vehicles were being built. So we had the EV1 was one of the first electric main production vehicles. Before that, even in the 70s, they were making electric vehicles in small batches, many different companies, 70s, 80s, and then the 90s. But it didn't really get really big until, or really popular until Tesla. After they crushed the Toyota, Honda, basically every manufacturer had a prototype electric vehicle that they made for California, basically for California around in the 90s. But they all crushed their vehicles. They didn't pursue it. So, after that, Tesla really, came on. And, of course, they asked us some questions as our racing team. We knew what we were doing with the lithium, and they asked us a bunch of questions. So I got to work with them a little bit. But that was Einhart back then.
So that's how you got into the battery industry?
No, our racing really brought us into the battery industry.
Okay.
That's what we were working with A123 systems back then.
So what were you doing for the racing? I mean, you were doing electric racing. What was the...
Yeah, electric drag racing, quarter mile. Yeah. So made lots and lots of records with that. A lot of different teams. We were able to set a lot of records over the years, that's for sure, with a lot of different teams. Got to work with a lot of different companies. Got to work with on the Volt project a little bit with GM. And then I also got to work with, Mythbusters, along with some other people on my team, Steve Sikora and a bunch of other people. We went down there to prove that electric vehicles aren't slow. Got to work with Jamie and Adam. Both those guys. It was really cool. That was really neat.
Got it. So in the 2000s, you started working with electric racing. Take us like 2010, you seen the electrical car come to fruition. And as I believe Doroni started in 2016, that's when Doroni reached out to you, I believe, 2016, 2017.
Yeah, 2016, 2017. Around that time, we started to talk about, hey, 2015's already come and gone. That's when Back to the Future said flying cars was going to be here.
Right.
And as you can see up here, you probably see,
Right.
I don't know if you can see those, but some of the inspiration. But, we were always Jetsons fans, just like everybody else, the cartoon. It was like, well, this is the time. Where are they?
Right.
And we're like, well, if they're not going to do it, we're going to do it.
Right.
We'll figure it out. And so we started building I started building the electrical system for the very first one. It's outside, actually.
Right.
We built we built 3 different versions, actually. This is one of the first versions.
Right.
And the first version had 3 ducts, basically.
Okay. Had
1 in the back and 2 in the front. It was a single-seater, very small, fits in your garage. We found some flaws in the design. Not enough thrust in the rear. The duct would have to be so large. We didn't like the design. So we switched it around to a 4-duct design, similar to what we have here now.
Okay.
Still twin props, so you have redundancy on each duct, which is really cool. So if one goes out, you can still fly.
Right.
And it flew really nicely, and we're like, okay, this is cool, but it's still, it's more like a toy, unfortunately.
Right.
It's more like a hobby vehicle. Not really the one we really wanted,
Right.
which is the flying car, like a real car. That's what we were really going
Got
for.
it. So just to walk you through a little bit. So it's 2015. You were always wondering, where's the flying car is happening. Out of the blue, Doroni reaches out to you and says, "I want to build a flying car," and you're like, "What?" You're like,
Yeah, let's do
just,
it. This is
okay.
great. No, it's a great challenge. It's really awesome. It's let's do it. It's very cool.
It's like, what did you see at that time that like, okay, it makes actually sense to pursue this technology versus like, in the early 2000s? What did you see happening
Yeah.
at that time for the future and how technology is going to evolve?
Well,
You say like, this is actually possible to get done.
yeah, you're correct. I mean, it's like you see, this is going to happen. It makes sense. That's the issue is like, and Jerome contacted me because I had set so many records and I was innovative, the first to do a lot of different things in the electric vehicle racing field, which is pushing the edge of technology. It's really being the first to do something that's very, very difficult. Along with the teams I worked with, they were always pushing the boundaries. How fast can we go? How quick can we be? How much power can we create? Can this replace gasoline? Yes, it's possible. That's the really cool thing. We could keep up with the gas cars. That's the vehicle. It's really awesome. So I thought it'd be a great choice. It's a choice. People could choose what you want to have. You can have either or. You don't have to be limited anymore. You can have an electric vehicle if you want it. That's kind of the thing is like people didn't have a choice. They couldn't buy a flying car. They had no choice.
Right.
Nobody was willing to step up and put their money where their mouth was, kind of thing. It's like they weren't really willing to do it. They couldn't get it. I was really shocked. You got all these big corporations and you got all these people with lots of money. And why aren't they putting their money into something that's the future, as far as transportation? It's very, very crazy and thinking about it. And even today, people are hesitant, and I don't know why. I haven't got a clue why. The skies are beautiful outside, and why wouldn't you want to go up in the sky and enjoy the view, when you're flying?
So is it that people might be afraid to jump in and do something completely new?
Well, yeah, everybody has, fears of breaking boundaries, breaking down walls, and stepping beyond the normal, stepping out of the norm. Everybody has those fears, but I don't really have that fear as far as doing that.
So saying your background is all about constantly pushing forward technology, batteries, seeing what you can do, what's your next challenge, and when they're on call to you, this was like, it's doable. I believe it's a big problem that we need to solve, right? There's the traffic congestions we have, the way we transport is not efficient. The roads, you're relying only on roads, and he said, like, listen, let's jump into this, and we can do this. Now, fast forward, now it's 7 years. What developments, what advancements have you seen as an industry? Because when you guys started in 2016, 2017, no one was really working on eVTOLs. It really started, I believe, when Uber, started with their air taxis, correct? In 2017, walk me through like how the industry, once you started, and what pushed the industry forward.
Are you talking about like the when the air taxis came about?
Yeah, because that was electric. That was the first introduction to electric aviation.
Well, they were just other people were seeing the same thing at the same time we were seeing it.
Okay.
It was like everybody was waiting for this to happen. There's other people that are innovative and creative as well, so they were also deciding, hey, now's the time. The time is right. And, technology has gotten to the point now with the mass production of electric vehicles and the charging stations and all that sort of stuff. It makes sense. It's only going to increase. the number of charging stations and so forth, they're only going to get more and more and more. They have to provide the needs of the electric vehicles being purchased. So, there is infrastructure already available for us.
Right.
That's really cool, is that we don't have to rely on, hey, we have to design this, then we have to do this, and then we have to do this. No, it's already built. A lot of it's already made. We can piggyback off of that technology, which is nice. We don't have to recreate it or design it totally differently. That's the cool thing.
So you're saying the electric cars really was a stepping stone for this industry?
Absolutely, yeah. Yeah, if it wasn't for some of the technology that was created for the electric cars that we worked on, this wouldn't happen.
Right.
It would be, people would have to do what Elon did, is bootstrap it up completely by putting the charging stations out there yourself and so forth and so on. Whereas right now we can rely on that infrastructure that's already been built for us, which is nice.
Awesome.
It's
Okay,
a lot cheaper that way.
So over these years, from when you started to work, you built, I remember the first prototype in 2017. You tried different configurations, I believe. Can you walk me through a little bit, like the progress and what challenges have you seen that are going to come up, and what you guys really were focusing on to solve, from the electrical engineering part, of course, but overall on how you guys saw the vision of the future of flying cars and how to build a vehicle that's actually going to serve that purpose. Because most people are so reliant on, like, oh, a car should have wings and it should fly, right? A lot of people that they're very, like, that's what they grow up with, understanding that a car is going to fly. And actually, as we see it, most of the cars, they don't actually look like cars, but they're just very simple and easy to use, very compact. So what was the key focus you guys having when designing the vehicle for the future of?
So there's a lot packed into that. We can break it down a little bit. But, some of the challenges we had in the beginning was that, there was really nobody building the motors, the props, any of the things we needed to purchase off the shelf. Not everything needed to be custom made almost. Nobody was in this industry at that time. So there was nothing being thought about for aircraft type electric vehicles. As far as the control system had to be all custom built to a large degree. There was nothing off the shelf at that time. Nowadays you can buy something off the shelf that's very sophisticated. And that came about with the mass production of drones as well, drone technology. So that also has helped us through the years. Is the sensors, the designs, that sort of thing has improved, and we can piggyback off of that now and make it even better. So a lot of the things we're taking from a lot of different areas and incorporating it into our vehicle. So it's not just one thing that's changed, or like a few different things, but a lot of things have changed to make this happen.
Got it. And design-wise, as we talked about, like, this looks more like a drone, airplane.
This is a hybrid.
It doesn't look like the flying car that people were thinking.
Because what we were thinking, what a lot of the movies and everything is you're going to drive on the road for a while and then you're going to fly, and then you're going to drive on the road and you're going to fly. And we just kind of said that's kind of ridiculous. You don't have to drive on the road. You can go straight from flying to where you want to go to flying where you want to go if it's small enough. You don't have to, more like the Jetsons in that way, where he would leave his house, he would go to work, he would leave his work, go to his house, you know. He was flying back and forth. He didn't drive on the road.
Right.
But in some of the movies, of course, you know, they gave us the idea of, oh, well, you just, you know, like a hover vehicle, or, you know, like the Back to the Future, where you're driving sometimes, you're flying sometimes, that sort of thing. But this is going to be transportation that is very convenient because you don't have to take a road. You know, you don't have to go to a stoplight. You don't have to even. And the vehicle itself, it has aerodynamic features of an aircraft. So it's more like an aircraft. You want it with wings. You want it with, you know, to save on fuel.
Right.
That's the whole point of the wings. We wouldn't even put the wings on there if we didn't need to save on fuel. But right now we need to save on fuel.
Right.
We don't have the amount of energy that we would like to have in the batteries that would be perfect for doing a complete hover all the time. Right now we need to fly like an airplane to a certain degree.
Got it. Awesome. So now fast forward to 2022, you guys have developed multiple prototypes. We flew the H1 in the warehouse. Tell us what you've learned over the past 7 years during the progress of what it is actually going to take to make this a reality. Like, what is the next stages of development of really perfecting this so we can deliver this to customers really soon?
What's the next stages of development?
Yeah, but first, like, what have you learned over the progress of the electric components? What do you see actually possible and feasible for this industry?
Well, it's only getting better. That's the cool thing, is like all the components are getting better each day. We are pushing, you know, the companies as hard as we can to design parts strictly for us. And now you'll see a lot of the electrical companies are actually starting to promote this. They're designing catalogs for this. They're behind it 100%. So we're working with a lot of those individual companies to design parts for us, you know, so that we can have a specific thing that we need for this vehicle. So, you know, it's progressing really, really good. Things are getting better each day.
Got it. So you're saying, maybe because most of the people ask, like, when is this going to happen? It's 20 years away from us and everything like that.
Oh,
like,
no.
What do you say to people as you're, you know, most people are just talking, you're actually building it. So if you can give us the perspective of someone that's actually worked on this for 7 years and understands the technology inside out, to explain to people why this is actually happening now and this is not a dream anymore.
Well, no, the motors, the technology, the props, everything has come forward now and is at the level that we need to have. So even the cells are getting better and better each day. They're being pushed by mass production, by gigafactories. So you've got a lot of different cell manufacturers starting to produce millions of cells a day, pretty much is what they're trying to do. So the mass quantities of those cells and them trying to make their cells better and better and better has pushed their technology along the same time period that we were needing it, which is great. So there's very few items on this vehicle that need to be like super custom, you know, that we'll have to design ourselves. Now, some of the software and some of the technology and it's going to take a while to develop some of it. It's not going to be easy. Nothing's going to be easy about it, but it's going to be a challenge on some of the different. But now we've got the new AI, you know, that before we'd say AI and people would laugh at us.
Right.
And we go, no, if it gets intelligent enough, it should be able to do what we need it to do. So if we incorporate some of that into the vehicle, just optic recognition systems and so forth, no problem. You put cameras everywhere, it can pretty much fly itself. It's pretty much autonomous, along with the autopilot technology that's come along over the years. It's all coming together. You can tell, it's just, there's nothing really to stop us.
All right, so you're saying that all the technology is basically here. It was the reason why we didn't have flying cars till now is just technology was simply not available. It wasn't that
people didn't really push the boundaries. They didn't want to.
right.
It wasn't easy. It's hard enough right now, but it was so hard back then. It was too challenging, probably. It would have taken them this long to get here. In other words, you can't almost do it any sooner than now anyway, in some ways.
Okay.
You would have been just building flying aircraft, which is, electric airplane. That's all you could build at that time. But now with what we needed to do is we needed to be, simplified flight controls. We want it so the average person can fly it very easily with very little training. You don't need much training at all with the vehicle. That's what we're doing.
All right, so we're at a point now where in 2 years from now, someone can purchase this, click in. Like, how would it work? Like, for someone to...
Yeah, you'd select your destination. It's going to figure out what the safest route is. It's going to calculate the amount of fuel you have on board. In other words, how much electricity you've got stored. And it's going to say you can make that range, and it'll give you waypoints and so forth, safety points. And there's a lot of technology going into that. You'll also be hooked up to the FAA ADSB, which will give you, you'll know where you are. You'll know where everybody else is. You'll see the other aircraft. You'll know what the weather is. You'll know what's going on. This is a fly by visual only, basically VFR. So you're going to only fly in the daytime, and you're going to fly it in good weather. So that's the restriction you have in that category of the FAA.
Right.
But it's going to be very simplistic, and in fact, it could be almost 100% fully automated. But right now, the requirements say that you need to still be in control of the vehicle, which means you're just going to have a simple joystick control. You're going to push the joystick and take off, and you're going to simply just hold it while it flies, basically.
Right.
So you're not in control of, you don't have to worry about, do I have to put the rudder on, or do I have to do this, or do I have to? No, it's all automatic. The vehicle is flying it for you. You're just telling it where you want it to go.
I got it.
It's that simple. It's so simple.
So you'd say it will basically be a robot? Like
You could literally call it to you at
Right.
some point in time in the future. You could just pick up your phone and say, "Come to me." And it would take off, and it would land, and it would come to you.
Got it.
It's not beyond the capabilities of this vehicle.
Right. So you already got into the FAA, regulations a little bit. Can you elaborate a little bit? A lot of people have questions about how the FAA is looking at a vehicle like this. Most people say it's never going to be allowed. There's so many different questions. Look how people are driving on the roads. They're going to drive in the air. Like, all these type of, people have real questions. Like,
Yeah.
I believe it comes from a lot of people are not familiar with the FAA regulations, and they don't know how the aerospace works.
Right.
Yeah.
Right.
So maybe you could elaborate on that part a little bit so people
Yeah.
understand how this is going to work.
It's that's one of the biggest questions, which is interesting to me. It's how people are thinking. I don't know why, but this is some sort of blockage, mental blockage people have, and it needs to be overcome. But it's basically they're saying, we need regulation. We want regulation. We want lanes to drive in the air, and blah, 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 blah. And I'm like, you don't really want that. You want to follow the rules that have already been in place forever. You don't really want to be limited where you can travel. I mean, the cool thing about this is it gives you freedom to fly wherever you want to fly as long as you follow the correct rules. There is already rules in place of how to fly,
Right.
so that you're in control of the aircraft. You tell it not to fly into somebody, basically, So, and there's lights on the vehicle, and you'll know where you are, and you can see this. The air is not crowded, and you got to think three-dimensionally too. You've got height, you've got enormous amount of space. You're not confined to a narrow road.
Right.
You don't want to be. In fact, you don't want these things stacked up in a narrow space. It's more dangerous. It's okay if you're flying around. If you're away from each other, it's even safer.
Right.
So it's like, I don't know why people are thinking that way and why it's needed, but it may come to that point if there's enough of them in the air. I can see where it's overcrowded and there's too many vehicles flying around. Okay, fine. If you get to that point, but then it will be computerized. It will be automated, and you won't be flying it at that point.
Right.
At all. They'll take away you'll be putting a destination in, and you'll be sitting back and going to sleep pretty much.
Right.
You're not going to be flying it, at that moment, because you cannot tailgate another aircraft and then if you don't know his speed and your speed, and if he's slowing down too soon and you're not paying attention, it's not good to have these things in like a traffic lane, in my opinion,
Right.
Without fully automating it, autopilot.
Got it. But that's something you believe is going to be
That's
way
way
down
down
the
the road. I mean, we're looking at probably 25, 26, the FAA will bring in some of the regulations for these things. That's what we're looking forward to. They're going to vote on it, and it's going to be passed by Congress, hopefully. And then that brings in that's the new rules for these vehicles. And then we'll just follow those. But you're looking at probably 2030. And there literally have to be billions of these things made by then.
right.
And it's not going to happen. It's millions, yes. Billions, no.
Right.
It would take a lot of money to do billions. And we don't need billions in the United States. There's only 300 million people or whatever it is. I'm not for sure. I haven't looked lately. But 300 million people are not living in Florida.
Right. So you're saying that it's going to be
You don't
a
have to worry
limited
about
quantity of how many we're going to have. It's not going to be
It's
something that everybody's going to have.
population density. Think of it as population density. If there's, say, every single person has one. They have one per family or whatever. How many is that? It's not that many when you think about it. It's not going to be that many in Florida, that's in this area. There's plenty of space in the air, three-dimensionally. You can fly, even we can fly up to 10,000 feet possibly with this. We're going to check it, but
Right.
it's if we are allowed to fly up to 10,000 feet, you could have stacked 10 high. You're still 1,000 feet apart from each other,
Right.
approximately. So even if you're on top of each other, that's 10 high, 10 wide. 10 times 10 is 100 vehicles in one car length long, right? So if you're going, it's the quantity you can get into the air is insane. The amount of vehicles you can get, millions of them could be flying right here, and you would hardly even notice they were there.
Wow. So you said, but this is not something we have to worry about.
Yeah, it's not a worry
It's
to
not
me.
even
It's not even a thought to me. I go outside, I look up in the air, I don't see a single plane.
Right.
I don't see a single aircraft half the time. If I'm down by the beach, I see them coming into Fort Lauderdale Airport, where we're not allowed to fly in that area.
Right.
We're not even allowed to fly around the airports. That's a keep-out zone.
Right.
You're not allowed to land at those. You can land at a specially designed place for eVTOLs only,
Right.
that are being built here in Florida and other states. Sure, you can land there. But so therefore, you're not in the air traffic area. You're flying around it, where there's nobody flying, pretty much, except private individuals. And that's what you would be. You would be a private individual flying.
Let's talk a little about the certification and the FAA regulation. How do you see that shaping out? Like, what is this actually going to require someone to fly at the H1-X?
Yeah, so the FAA has been mandated by Congress to come up with rules and regulations for this type of a vehicle. So it's going to apply to us and a few other categories as well, new inventions. So they're really required to make these rules by law. So it's not like something, we're going to have to wait quite a long time for this to happen. No, they're being told they have to do it, so it's going to get done.
So you're saying the FAA is actively working in...
Yeah, so they have a mosaic right now,
Right.
which is some new, it's a proposal. So it's under, they're looking at the questions that they received from the pilots and the industry, and they're looking those over right now. So they will come back with a revision probably in 2025, or they'll be answering those questions. If there's nothing major, then they're going to move on.
Got it.
So, yeah, I'm just saying it kind of in layman's terms. It's not really. It's a lot of still a lot of bureaucracy that has to happen. It's not going to be easy to get through, but it'll happen sometime. Hopefully in 25, if not early 26, when the new Congress comes in.
Oh, got it. And like, are you actively working? Like, what's your how do you work with FAA? Are you in touch? Like, or
We're not directly in touch, but we're working through the standards committees. We're working with those people as well to set the standards that the FAA will use in the future. So that's the goal, is to get, these standards finalized, basically, for what needs to be done.
makes sense. Okay, so now that we know about this, now can you walk me through a little bit the H1-X? I would like if you can walk us through like the design. So if you
Okay.
can explain to me like what's behind this design, why did we come up with this, and what's so special about it?
So this is our latest design of the vehicle. The duct system has been optimized to be a lot shorter here on the front and the back, so it's more aerodynamic. There's specialized air channels here that you can see on the wings.
Mm-hmm.
This helps with airflow around. That's patented by us as well. We have dual props, dual motors in each duct system on each wing. So you'll be able to, if one motor goes out, you're going to be relying on it'll that next motor will go up to full power, and they'll balance via the other motors. So you'll still be able to do a controlled landing with one motor out.
Got it. So can you focus on the ducted technology and why this is so important? Because most companies are not doing that.
This is extremely difficult to do. What we're doing here, and what we're trying to do is basically you have a giant hole in your wing and you've got air flowing through it. So we're designing this so that it's optimized. I'm not the expert on that by any means. The aerodynamic team is really the experts on that. But basically, we're using the propellers as part of the wing, and by controlling, because we can computer control the prop so accurately, we can generate the right amount of force here that will create a simulated wing area.
Interesting.
If that makes sense. It's very complex. And because of the way this is, we need to have the air flow around it correctly. And that's what these guys are. And those are specially designed, computer designed for that. So this hasn't been done before. It's never been done before, really. It's been tried a few times by the Air Force, but it's never been really put into production.
So what do you see the benefits? What would you say this would improve the vehicle, and why the H1-X stands out versus anyone else?
Well, it's nice because this is fully enclosed. It's not showing everything here yet, but it's going to be. So the likelihood of ever touching the prop has been reduced dramatically, and this increases efficiency by having a ducted system. In theory, it should be close to 40% increase in. We'll have to measure that, of course, as we're building this. But it's safety-wise, it's very good. Nobody can walk up to it and get into the prop. An open prop design is very dangerous, especially if you're landing in the public space, where there could be kids or dogs or something running around. You don't want them to run up to the vehicle and get hit by a prop, because they're pretty much invisible when they spin at the speeds that we're spinning at.
Right.
So there'll be shielding and so forth underneath as well. So it also helps with bird strikes. An open prop design, although it's nice and it's easy to do, it's efficient too in some ways. But the problem with that is you're open to all the elements. I mean, if anything strikes it, you could lose the prop. Whereas this, it has to go hit the wing first, and it has to do a lot of damage before it could even get into the prop system.
So our main focus is the prop system, right? This is really what our patent is for. How important do you think this is really for a vehicle like this to have enclosed ducts?
I think it'll be mandated. I think it'll absolutely be mandated. There's accident-wise, debris, everything. Anything could get you into an open prop design is so dangerous. I don't think they're going to even allow it to land in public, to be honest with you. You'd have to land at private airports, or you have to land at a Veriport, which was, it's specifically designed for these guys.
Got it. What about the electronic components, the batteries? How do you see the battery technology? How is this going to fit in? And what are you working on? How do you envision the battery system to work here?
Well, the battery system is going to be included in behind this passenger area here. There'll be a firewall system built into that. But our technology that I've been working on for many years now, is going to be fully I'm not going to say it's going to be 100% fireproof, but it might as well be. It's going to be as close as possible.
Right.
So unlike EVs, cars, they're the risk, we're lowering the risk down completely as much as possible. And it's going to run through a lot of testing on that when those packs are built.
Got it. And how's the charging going to work for, what do we work on that?
We'll have a basic onboard charger. It's not going to be anything pretty much like an automotive charger. It's not anything special.
Right.
But so it'll work with any standard automotive charging system. We'll have different adapters available for your vehicle, so you can charge up your cells. When you can charge at home very easily. We have an option as well if you want to. If you need to do really fast charging, we can create that at your home as well. And you can do fast charging from like a Tesla charging station once we get if Tesla wants to allow us to do that, we can do that.
So you're saying the charging will be very simple, just like an electric car?
Just like an electric car. You don't have to worry about it. You'll be able to see where your charge level is on your phone system, any phone, Apple, Android. So, the vehicle will notify you when it's full. It'll let you know what the level is, how things are going. Yeah, it's very simple. Plug and play. You don't really have to.
How do you see this advancing? Like, we know we have about 40 minutes flight, about 60 miles. Like, how do you see the battery technology advancing? Let me take this.
Well, there's a lot to advance on that, actually. As the cells get better, we're going to put in newer and newer cells. The good thing about our system is the battery system is modular. So this is not when the batteries go bad, you throw away the vehicle design. I don't like that design, never did. When you put the battery in, it should just be something that's removable, in other words. And the idea is that you could actually remove this battery in we're hoping to make it so it's really easy to remove in less than 15 minutes.
Oh, wow.
So you could pull the whole pack out and replace it if you need to. So there'll be missions or critical missions where people need to do that, and they're going to have batteries pre-charged at stations and ready to go, plug and play. So they'll pull the batteries out and put in new ones, and then they'll charge those up, and on the way back they pick those up or whatever. There's different scenarios that different companies and different people have asked us to do, and different organizations. And so we try to accommodate all those different features, of course, for our battery technology as well.
Okay.
But we have basically two wings in the back here. We have the landing gear system is actually a wing as well, which that's very unique. I don't think anybody's ever done that. And that incorporates, lift via the landing gear. So we have more stability with this vehicle.
Okay. Got it. So you're saying the actual ducted here.
You can show.
Yeah. So the landing gear is an actual wing.
Right.
So what is this, having an actual wing here, what does it help us with?
It helps us with stability as well, but it's helps us with lift and range.
So you're saying we get additional lift?
Yeah, we get additional lift with that as well.
So you get longer range, and we could be more compacted, so we can have smaller wings on top.
That's the idea, is to keep our wings as short, as narrow as possible. So we're really trying to optimize this to be a short vehicle and a narrow vehicle to fit into a two-car garage.
Got it. So it's basically going to work. You come out of your garage, you go up vertically, and then is there any tilting? These don't tilt, right? These are...
No, they're rigid, so they won't be tilting. Nothing will be moving. We're trying to keep the whole system as simple as possible. which makes it hard on our side, of course, to build the flight controls. But none of the motors tilt, none of the motors move from their position, so you don't have any wear and tear on those motors because of centripetal forces. But what was it saying on that? So
I'm so saying you're going up vertically.
yeah, we're going up vertically.
And how does the transition?
So you're wanting to know about the transition.
Yeah.
There's a couple of methods for transitioning that we're looking into. Basically, you'll be hovering when you're doing this. So you're using all 8 motors to just basically deadlift you off the ground. When you transition, the pushers come on. Those 2 pushers underneath.
Okay.
They're going to come on, and you can use the wings as an attack plane to lift you to the next level, basically at an angle. So you can use that to increase your height if you want.
So you could go vertically, and you can also go like a plane?
Like a plane, exactly. So you can do both. There's also another option of you just use the power lift and the pushers, and you kind of go up at on a level plane. But
in a basic scenario,
it uses more power.
Like if I come out of my house, I want to go up vertically.
So you get to a certain altitude that you feel comfortable, and then you would put it on the pushers. You'd start going forward.
The pushers will.
You'll create lift with the wings. The wings will you can change your attack angle if you want to go up higher. If you want to stay at that level, just pushers straight on.
So it's very comfortable. I mean, from what I'm saying, there's no movement, not much.
Yeah.
Movement, really comfortable, right?
That's the idea. We don't want to. I don't want to make the passengers sick. I mean, we don't want to have it like a roller coaster. So we're trying to keep the aerodynamics as gentle as possible on transitions.
Yeah. Because a lot of people are afraid of flying.
Yeah, I think you'll feel a lot more comfortable with this, believe it or not. The final product.
Biggest question most people have: what is the difference between this and a helicopter? Like a lot of people, we already have flying cars. It's called a helicopter.
You've heard that, huh?
Yeah, many times. So people, how would you explain the difference?
This is totally different than a helicopter. I mean, in many ways. I mean, it's just you've got the agility of a drone, and you've got the aerodynamics of an airplane, so you can fly like an airplane. A helicopter requires all of its power to be created off of that blade on top that is spinning. It's creating basically a virtual wing as well, and creating lift at the same time. And you're relying on that to move you forward. I feel this will be a lot more maneuverable. I could be wrong, but it feels like we're going to have yaw as well on this. So basically, you could hover and point, rotate around. Of course, you can do that with a helicopter as well. But you got the ability to transition and go into a forward flight like an airplane, which you don't really have that with a helicopter. You're more of tilting the blade and using its power to push you forward. So you won't have that kind of a feeling with this. You'll have more of a straight flight feeling.
Right. And what about the electronic components and the maintenance? Talk a little bit about that.
Yeah, it's going to be very easy. There's hardly any maintenance on this at all. Battery pack can be replaced at any time. It can be upgraded to new design cells at any time if it needs to be maintenance. You'll be notified, of course, if there's any problems with the battery pack. So it'll notify you if it sees some anomalies happening in the battery.
Right.
Let you know, give you a warning. You could also replace just one module out of the 8 modules. So in other words, you don't have to replace the whole thing. You could just replace what needs to be sent in. And the cool thing is you can send that in via, basically it looks like a piece of luggage. And you'd ship it to us, we rebuild it, replace it, or upgrade it. There's many options for that. we're also utilizing like a full circle. Department of Energy is talking about this, but I've been working on this for many years before they even started talking about it. But basically, it's a circular design on the battery pack design on that. So that will be utilized in multiple secondary uses. So say you're not getting your full flight out of this. You're like, oh, okay, I need a new battery. I'm not getting the full flight I want to have out of it. The cells are getting weak. Those cells will go into a secondary market. That secondary market will utilize it either for the power grid, or it'll utilize it for another piece of transportation. So we're making this so that these can be used for many, many years. And with the new AI algorithms that they've been coming up with for lithium cells, I mean, technically these cells could be used for almost 30 years, is what they're telling me. That's what they're telling me. It's not my idea. It's theirs. So we'll see how that pans out, but these won't become in the waste. In other words, they won't be put into trash for at least 30 years, which is awesome. So in other words, and then once they're not going to go to the trash anyway, they're going to be recycled at the end anyway. Right. And recycling systems are coming online very rapidly for lithium cells, so you can get almost 100% back. And what's left over is a very minute.
It's like, so what do you think of the state now? Like, a lot of people are worried about, all these electric cars. In a couple of years, they're gonna be disposable or something. Like, is there?
Well, that's kind of the problem with the electric car is the battery pack on these are either hard to replace or impossible to replace on some of the cars. The owners don't feel like it's their responsibility to do it, which we're putting this on the owner. He can make the decision whether he wants to replace it or not. We're going to try and keep the cost down as low as possible on that. So unlike automotive batteries, they're very expensive to replace because you have to replace them all as one section. Whereas us, you could, I want to replace 1 out of 8, and then our algorithm will take care of the time usage on the cells, of course. But your cars are pretty much designed to be disposable, and I don't like that idea.
Well, what do you think is going to happen with the batteries? Are they going to be recycled?
They'll be recycled. Okay. Yeah, they'll be put back into the recycling system. I mean, some of the cars that are recycled will probably go into our new lithium, that goes into our batteries. That's the way, just like lead acid's almost 100% recyclable. When you take your battery back, they grind it up. They take the raw materials back out of it. They synthesize it back out. They take the chemicals back out. Some of the plastic they can't reuse, but that could be melted down and used in other products. But then it gets put back into a new battery. So the battery you're using in your car probably right now has been recycled we don't know how many times.
Oh, got it.
The same material is still in that battery. It's just being reused over and over again, along with some fresh new parts put back in.
Got it. So by us making the replaceable system will actually make our vehicle last a lot longer?
Absolutely. So the vehicle can last as long as the frame is rated, and the FAA allows us, it depends on the rules and regulations, and what we come up with as far as the mean time before failure type system, when parts need to be replaced, in other words. So once we find out what those numbers are, we'll tell you what needs to be replaced at what time in the future. But technically, if you replace those parts and you do the maintenance properly and you take care of your vehicle, it should last forever.
Wow. So it's definitely a more sustainable option.
Absolutely.
Than an electric car.
Yeah. Yeah, you don't have to worry about it. It's going to be made out of carbon fiber. It's going to be made out of composites no rust. It's not going to rust or corrode. It's not going to deteriorate over time. So it'll last pretty much forever.
Got it. Um, Makes sense. So let's go in a little bit about yourself, like your work ethic. If I may go in for a bit, you know, I mean, many people, work on different technologies, and there's certain drive that people have that continuously, push through the boundaries. And I know you personally. I've seen you like sitting here like till 1 a.m., 2 a.m. Like you literally sleep here. Like, how do you do that? It's like
It's tough.
what gets you there? It's like what the why? Like what's pushing you to do that?
Well, it's the goal. I mean, I've had, like in my racing, I've been first to a lot of different things.
Right.
The first to 200 in 2 different vehicles with electricity. Nobody else has ever done that before.
Oh, you did 200 miles.
Over 200 miles an hour in a quarter of a mile.
Oh.
So if you think about it, you look at your speedometer and you're looking at a quarter of a mile as you're going down the road. And you think, could I get to 0 to 200 from a standing still in that amount of time? It's amazing. It's not very far. So, it's the ambition to try and get this done, I think, is part of it, but just the excitement of wanting to accomplish it as well, getting the accomplishment done. I think that's part of it. Pushing the boundaries of technology is interesting.
Right.
It's exciting.
Yeah, because to me it's like, I feel bad leaving here sometimes at 9 p.m. or 10 p.m.
Even
and you're
early.
still here.
Yeah.
And you're still here, and it's amazing to see. So,
Well, I have a lot of work to do to make it happen.
right.
That's the problem.
Yeah, that's a continuous challenge,
Yeah.
but
It's a challenge.
Yeah, this is, I believe, one of our core values and core culture in our company is really, pushing that, everybody pushing the boundaries of and everybody in their field and what their expertise are. With that, like, what's your vision for Doroni? How would you want to see this industry play out over the next 5-10 years?
Well, I think, along with the Veriports and the other infrastructure that's going to be put in, I see people really utilizing this everywhere. I can see how disruptive this can be. It's probably going to be very disruptive. I expect that it's kind of like the early adoption of the cell phone, where
Okay.
people didn't see the value of it. I mean, people had it in their cars. It weighed. A few people had the portable units, which weighed 3 pounds, and you're lugging that around with a big battery pack. It was the early adopters of that technology. It was very expensive for a cell phone back
Right.
then. It was only for the very, very rich. I see this more like an Apple startup, to be honest with you.
Right.
It's more of like Apple technology. I mean, we're only going to get better with this technology.
Right.
It'll get more efficient, more useful. But the world will change around it. So you'll have, the roads are getting bad enough. They're always under construction. A lot of them are anyway.
Right.
It's hard for the government to maintain it. Where we go, we don't need roads.
Right.
So it's pretty nice. They
It's a
don't have
famous
to
Back
worry
to the
about
Future.
it. Yeah, I know it's a
Right.
Back to the Future quote, but it's a good one. Yeah, so I see it more of people will adapt very quickly to change, and they will once they get used to it, they're going to absorb it very quickly. That will cause lots of other things to happen on infrastructure. So you'll see buildings probably putting in rooftop landings. They have a lot of space on top of these malls and buildings where they aren't being utilized. If you just put a layer above that building, you keep the building cooler during the day, especially in the heat. You'd have a secondary roof, which would protect it from rain and hailstorms and natural disaster type stuff. But then you have a landing area up on top that would be available for charging, and people could come down into the building and shop or buy things or whatever. I see that happening very quickly as people say, man, this is a great idea, but how can we, how instead of using up all the parking lot space to land these guys in, where are we going to put them, kind of thing. So I see people adapting very fast to building things. So it will create jobs is what this is going to do. It's going to create a lot of new jobs is what I see.
So you're saying it's going to create a whole new economy?
I think so. Yeah, everything that has ever come out before has done that. It's always created a new type of economy that people didn't think of. You can utilize this farmers are going to utilize this right now. They're talking to us about it right now. They're going to use it to look at their crops. They're going to use it to look at their animals. They're going to fly around where they have to use a helicopter right now. This is a lot cheaper. They just plug it in. We've talked to people on oil rigs. They want to use it for flying out to the oil rig. Now they don't have to hire a pilot to do that with a helicopter, which is very costly, and they have to schedule it and all that sort of stuff. Each rig could have its own unit. The people on the rig could be trained to fly it very quickly, and so they will be taking themselves out to the rig in the ocean or the windmill out in the ocean. We've been asked to do that as well. So these are going to become so useful, we don't even know all the uses they're going to use them for. I mean, if you own a piece of property out in the middle of nowhere, you can actually get to it now. If you don't have a road access to your property, now who cares? It doesn't. You just fly there. So
you're saying you can access remote areas. People will start living differently.
Yeah, Canada's asking us about it. They're asking us about it as well, because they have a lot of territory that's just wilderness, and they don't have roads to it. The area they want to go to look at. So the governments are going to use them for different things as well.
Wow. Awesome. So looks like there's a bright future ahead of us with Doroni, and I'm excited personally. I think everybody, our viewers and listeners constantly, people are really excited to see what's happening. But would you say that it will be transition from like horse and buggies to cars? Or you would say it's
I don't think people are going to give up their cars. I mean, that's what I want to... People can still ride horses even today. I mean,
it's like being from a gas car going to...
There just won't be as many
electric
of them,
car.
Probably. Many cars in the future.
Right.
People would decide, or this might be their second vehicle. They have a car and they have this. But I think people are going to see the convenience in it, and the ease of travel, the quickness you can get somewhere. No stoplights, no turning right, going on a grid, left, right, left, right, left, right, straight. It's just like, that's annoying. You can go straight there, diagonally. It'll take you a lot less time to get to where you want to go.
So you're saying this will be optimal for someone as another option. It's not going to completely... Cars are not going to go away.
At first, it will not completely take over. I don't expect it to. I expect only the people who are visionaries will come in and see this, and they'll say, yeah, it meets my needs. I can use it. There's going to be people say, well, I live in an apartment. I don't have the parking space right now. I got to wait until the apartment upgrades their apartment to allow me to park there. That's fine. It's going to happen. The apartment complex will say, hey, we need to, when we talk to apartment complexes, you and I have talked to them. They said, okay, we're going to put in here in Miami, we're going to put in a landing area for these vehicles in the middle of the hard part where we don't sell that many apartments, where the condos or apartments aren't that valuable. We're going to put in a landing zone right in the middle of the building, and we're going to leave the penthouse for the penthouse, and the penthouse will have private landing zone for their vehicle. And, that's just the way life's going to change. Life will change. It always does.
Saying it will change in a big way.
Yeah.
Awesome, because this is very interesting. We see a lot of our pre-order holders actually, some sports players, some high net worth individuals that value their time a lot. That's what I see a lot. And that's just about the flex. We just had one football player came in. Yeah. He was like, this is going to be one of the biggest flex that someone can have. But there's so many different. Yeah. Everybody relates to this vehicle so differently, and it's amazing.
Some people are almost like angry at it for some reason. I don't know why. But then other people, this is the greatest thing on earth. Now, everybody I've talked to loves it, but they always throw up these mental blocks about how am I going to fly, what's going to happen. Don't worry about it. It'll be settled. You'll be okay. Everything's going to be all right.
Right. What would you say to people that have calm. So many questions and so worried about it? And what would you tell them?
The technology will only get better.
Okay.
The safety features will only get better. There's no reason to really fear it.
Right.
Okay. It's not going to hurt you. That's the idea. That's the idea. We have a parachute system. In case of an emergency, you'll come down. We've already talked and discussed with, great people at NASA, and they were, there's lots of people working on this. Lots and lots of people working on it. So it's not something we're just pushing. There's lots of people wanting to do this, and from different angles. Some people are just doing it as a hobby, kind of like as a toy. Other people are doing it like an amusement park type ride. I know even Universal Studios or Walt Disney or somebody contacted us to use this as a ride. They may do that just to show off their place, or they may use it during their I think they were talking about using it for maybe the parade or something one time. So there's a lot of people with a lot of inventive ideas with this, and they'll also create inventive ideas. But people shouldn't be really worried about it. The technology will get better. They'll be very safe as time goes on.
Got it. Okay, awesome. What else can you tell us what you're working on and how things...
I can't really tell all the patentable stuff that I'm working on right now, but we're custom making a lot of things from scratch. I am anyway.
Right.
I'm working with some other people as well to make some. We're trying to make the electronics as kind of in a simplified way, which is kind of funny in a way, but we're trying to get rid of some of the old technology that just really irritated me over the years. It's been around forever and it never got improved, so I'm trying to improve it. Just the power distribution system, just the way power's distributed through. I'm trying to utilize less wiring in this vehicle, than standard vehicles usually have. Trying to optimize the entire electrical system for efficiency. And it's going to be a smart system too at the same time. So not only is it going to be, it'll be able to identify, and basically it'll be smart, so it'll know if there's problems, it'll let you know. It'll auto-correct those problems. There's a lot going on in the guts of this vehicle. A lot going on.
And what are you currently testing?
We're testing the props right now and the motor systems. So we're testing the propulsion system completely right now. So I designed basically a motor test fixture that will allow us to test different prop designs along with different motor designs, and we get tons of data from that. And that will be utilized to optimize the power structure that we're putting into the ducts. And so we will be putting a duct on this motor test fixture as soon as possible. And that will create, it'll validate all the test requirements that we have already. We've already got the numbers crunched in computer, but right now we want to verify it in real world against the computer models and make sure that the computer models are correct. You don't want to just say, oh, that's it, let's build it. You want to go through the actual validation test.
Awesome. I think we're actually going to do a video soon about it, and I think we'll post it here as well. So that's going to be pretty interesting to talk. Okay, so Derek, thank you so much for your time. Yeah. I know you have a lot of things to do.
That's true.
So I won't take more of it. Thank you so much.
It's been awesome.
Okay, have a good one.
Thank you.
Okay, thank you everybody so much for staying tuned in and watching. I hope you enjoyed. Please leave your questions, and if you have anything else you want us to discuss on the podcast about the flying car industry, about eVTOLs, please let us know. I highly encourage you to follow us on our social media platforms, learn more about our company and more about this industry as we're getting really close for it to happen. If you would like to join us, you can go to our Start Engine page, go to our website, learn how you can invest and how you can become a part of Doroni Aerospace. Thank you, and see you on the next one.